Good morning. Today we will talk regarding the digital image processing. First lecture, I will speak about transformation, and in the second one, I will start the image enhancement, which is the unit 2 or chapter 2 from our book. And it's one of the important chapter because whatever we should do with the MATLABs mainly focus on this chapter 2. Then try to learn and study more about this chapter. One more point that I should tell you that about the working on the pixel, I made one more PPT, but due to time, uh, maybe we will not have the time to load it on the means the speaking on the lecture. I request you that please you read it from the mock system. It has even one and two example about adjacency and some related concept about it. It's repeated, but it has some other words maybe will help you to study it better. Then just right now, I with Elba Bro, we loaded on the mock and you can see it there. Please read that part also. One more thing that I tell you, I hear that there is some national days in China that somehow maybe, or I'm not sure, maybe lectures are stopped. Uh, Maybe we will not stop our lecture and we have it on regular time because I'm worried about the parts that I need for your syllabus and I don't want to miss it. Maybe we will not, and if we didn't stop the lecture for that, what I will do that I will mm, going to put some practical part from these 8 days, 6 days, something like that. It means that I will not stop the lectures for this week. I counted in our syllabus. Let us reserve some time. And if we had more time, then at the end, we can cut the week. That is what we plan. Then, if everything is okay, we can stop for today. Just give me, please, Roy, one more feedback that I will stop the lecture, start the lecture from today. Okay, good. You know, what is one of the concepts that today we should talk about it, and even last week we talked, but let us expand it and speak more about it. It's transformation. Uh, why I'm going to talk regarding this transformation once more, because I think maybe deeply if we discuss, and now you have some view about the image, then the concept become more clear. Today I talk regarding the transformation, some Fourier transform, discrete cosine transform or DCT, and gray level transformation. And because in the MATLAB section, which we have work with this transformation, some concept and review of them will help us to study better. First of all, transformation, we know it as a function which can map one set to another set after performing some operation. This is the mathematical concept which we have regarding the transformation. And specifically for the image transformation, we are searching for the function or operator which can take an image and its input and produces an image as the output. Then remember, in the image world, which is our subject, and mainly we talk regarding that, we are searching for function or operator. And on the other side, we know that the input for this function is image, and output for that is also we know it as the image. Then, depending on the transform that we have, means that the method that we will hire to work, the input and output image may appear entirely different and have the different interpretation. Some people will use Fourier transformers. Some people will use principal component analysis or PCA, and some various special filter which people can use. These three are examples which used frequently in image transport procedure. How it will work on the image is something like that. Suppose an image is obtained in a special coordination of x and y, or if we think for the 3D coordination, we have x, y, and z. And there are many advantages if the special domain image is transferred into another domain. In which solution of any problem can be found easily. Think, suppose I have this equation of g, x, and y, then transform as the function which act on this f, x, y, and you remember that this f, x, and y, we know it as the matrix for the image. In this equation, we know that f, x, and y is the input image on which transformation function should be applied, and g, x, and y is the output from the proceed image of t as the t, which we know it as the transform function. This relation between input image and the proceed output image can also show something like S is equal TR, means that the both equations are same. But if I want to elaborate the parameters that we have in this formula, we can say that R is actually the pixel value or gray level intensity of X and Y, F, X, and Y, which is we know it at any point, and we know S as the pixel value or gray level intensity of J, X, and Y at any point. Then now what we learned that this transform which will be act any point on our picture. Or let us talk it better or speak more about it. This any point means that it should act on any pixel on image. A basic level gray transform has been discussed in some tutorial and some part that I give you before. And now some basic transform function we will talk today. One of the most famous one about this transform are the Fourier transform, which is mainly used for image processing. And in that, its intensity of image is transformed into the frequency variation and then again to the frequency domain. This form of transform uh, used for a slow varying intensity image, such as something like background of your passport size photo, and it can be represented as some low frequency components, and edge can be represented as the high frequency components. Then low frequency components can be removed and using of FD domain. This line that even I put it red, maybe some low frequency and high frequency concept in image. We will not know it better. In image enhancement, we will review, but maybe it's come in your mind after reviewing these lectures that where we should use which transform function, which the type and which work of the transform method. These lines will show us and give us some good line about the application of this specific transform. The process in this form is something like that. When an image is filtered in Fourier transform domain, it contains only some edge. And if we do the inverse Fourier transform domain to again a special domain, then also an image will contain again the edge. And Fourier transform is something like simplest technique that we can use to work. Then, if we want to see the formula in the two-dimension form, it's something like that, which now I don't want you to memorize it. I just want that you know this formula. And the matrix notation about this formula is something that I shown here. Just remember that this Fourier transform as the main formula or main concept in the mathematical part, it has this formula, and in two-dimensional, it's worked like this. But how it will act, it's exactly like the sample that I put on the Lena. See Lena pictures. If you take the Fourier transform of the photo, you will see the output that I shown here. Some properties for this Fourier transform noted, which had its symmetric unitary. It has the periodic extension and sampled Fourier. It is fast and it has the circular convolution. Have these properties in your mind. Later, again, when we work with the image, when we analyze the image with the MATLAB especially, you will have more clear concept about them. Okay, then as an example, again, one example I bring here, which is the some blurred image at the end and some good photo image we have here. See, if you take the if you take the Fourier transform on that, you will see that depend on the pictures, what will happen as the output. Okay. Uh, the second method that we just reviewed today, this is the discrete cosine transform or DCT, which in that coefficient carry the information about the pixel of the image. And also much information is contained using the very few coefficient, and the remaining coefficient contains the minimal information. This coefficient can be removed without losing some information by doing this, and the file size is reduced in DCT domain. DCT is used for lossy compression. Um, Let us see the formula. Formula is in the one dimension form is something like this. And as you see, the cosine form is highlighted in this equation. That is why they know it as the cosine transform. And you know that the two-dimensional discrete cosine also can be something like a star, and know it like this. I should tell you that this formula is just good to know the concept. What really we need in our subject is something that tell us the application as well as the act of the formula on image. Okay? Our course is not mathematical course that I tell you deeply about this mathematical, but you should know that what is the mathematical term, okay, and what it will do on the image. If I want to tell you the properties for this, we can say that it has the real and orthogonal part. It's not real part of the DFT. It has the fast transform and excellent energy compression, means that highly correlated data. See the photo that I put the DFT on that, and sorry, DST on that, and this discrete cosine transform what it do on the figure. Um, One question is that the image transformation application, it will use for various jobs. But if my application is fixed just to finding the edge of my photo or my image, mainly the method which helps me is Fourier transform. And discrete cosine transform is used for image compression. Remember this. Uh, and the last part of, or the next method which we fastly review is the gray level transform, which in that all image processing the techniques will focus on the gray level transform, as it operates directly on the pixel. And the gray level image involves 256 level of gray, and in histogram horizontal axis span between 0 to 255. And the vertical part depends on the number of the pixel in the image. If I want to say something regarding this transformation, we can see that for working on the image, which is the next topic that uh, today we will discuss, and we know it as the image enhancement technique. It has some formula as S is equal T multiplied by R. We know the R as the value of the pixel, and S is the pixel value before after processing. If now I have the R is equal to F, X, and Y, and S as the G and Y, then we can say R and S are used to denote the gray level of F and G at the X and Y. Um, this is some concept that today we will talk how this image technique, image enhancement technique will come to picture. But just remember some more points regarding the three type of the transformation we have. We have linear one, it has the linear relation. We have the logarithmic, and we have the power law, which all of them are shown in this graph. Okay, this is the first and fast review that I thought that because in the image enhancement word uh, or next lecture, we need it, okay? Because we speak more regarding transformation word, and something like that. That is why I prefer before that lecture have some talk regarding the transformation uh, concept and transformation method once more to review it. Then now we will start the two-day lecture, means that the main talk that we have for today, which is about the image enhancement. Okay, this chapter is, as I tell you, it's we can say the practical things on our image processing subject is based on this chapter. Till now, we have some initial concepts, but now we have some concept which we can work on that. Uh, then, if we want to again start it, let me share the new slide, and then again we can, yes, start. Uh, Now I'm going to talk regarding the main topic of today, which is image enhancement. First of all, please keep it in your mind that now our work is to do some action and having some work uh, on the photos or on the image? I don't know. The picture is okay or no? Just give me one feedback because I changed the yes. Okay, okay. A slide. Remember something. Maybe this slide it's make your mind more clear about the method and um, way that we have in image processing. Typically, the image processing technique or image processing work are divided into three parts. One is that image resortation, another one is information extraction, and one is image enhancement. Today we talk regarding this image enhancement. And if we want to talk very fast about these three concepts, we can see that in image processing method, um, the image resortation is compensate for data errors and noise and geometric distortion introducing during the scanning, recording, and playback operation. This is the concept for image resortation. For image enhancement, we alter the visual impact that image has on the interpreter in a fashion that improve the information content. And information extraction utilize the decision-making capability of computer to recognize and classify the pixels on the basis of their digital signature. Please have these three concepts in your mind that when we talk about the image enhancement, we want some visual impact on the image. Okay. Then, with this introduction, now we can start the talking regarding the image enhancement. And it's good to know that these three parts also have some more category. Suppose in image resortation, we have restoring the previous periodic line. We have the periodic line in stripping and drops out, filtering of random noise. We have correcting of atmospheric scattering, correcting geometric distortion. In information extraction, we have the contrast enhancement, intensity, hue, and saturation transformation, density slicing, edge enhancement, making the digital um, um, mosaics and producing the synthetic stereo image. In image enhancement, we have the produce the principal components image, producing the ratio image, and multispectral classification and change detection image. These are the way and method which totally I found for you and make it in this form of the graph. Then what is really the working on image enhancement or objective of uh, enhancement is that process an image so that the result will be more suitable than the original image for a specific application. Um, Suitableness is up to the application. Then remember that thing. Like any methods and any work, we should know the method, we should know the application, and then select the method based on the application that we have. Uh, this is very famous sentence that the method which is quite useful for enhancing an image may not necessarily be best approach for enhancing the another image. Means that based on the type of the image, based on the type of the application that we have, we should select the enhancement method. This image enhancement is going to improve the interpretability of perception of information in an image for human viewers, and going to providing the better inputs for other automated image processing techniques. Mainly, this work will divided into two parts or two main sections. One is that the special operation on pixel. Another one is frequency domain operates on FT of image. Means FT is as the frequency domain and fast and Fourier transform. If more detail about this enhancement technique we want to talk, we can say that in a special domain or in image plane, techniques are based on the direct manipulation of pixel in an image, and it will directly operate on pixel. In the frequency domain part, these techniques are based on modifying the Fourier transform of an image and operates on the Fourier transfer for an image. There are some enhancement techniques based on various combination of methods from these two categories. Image enhancement method can be point operator or some histogram equalization and matching, and application of that we will review. And for the frequency domain, we have the unsharp masking and homopathetic filtering method that we can use for that. One thing that we should review before continuing to the lecture is the concept of good image. What we know as the good image is the visual evaluation that we have from the image quality is highly something like subjective process. Maybe some people know the one image is good quality, other will say no. It should have some standard. Keep it in your mind. And it's hard to standardize the definition of the good image. Um, but now, maybe I'm not much more agree with this sentence because the technique that today we have in the image processing will help us to say that the minimum standard and more than that means that some threshold we have in the image world. But uh, on the other way, really the concept of what is good image and what is not the good image, it's people are talking regarding that. We can say that the certain amount of trial and error usually is required before the particular image enhancement approach is selected. And whenever you want to work on the image, you should test the other methods and then compare and say that this method is good or this method is not good. Keep it in your mind that uh, after working with this enhancement job, then we should first test the methods and say that which of them is better. Um, I think till now it's okay. We can have some rest, but before that, let us do the attendance, and then again we will come back for the lecture after some. Then now, what we reviewed today, first one was the word of the transform. Transform is nothing but converting from as the image and output as the image. Again, input and output is image, means that we have the same image. And then uh, again, one more thing that I should say is that the other word was image enhancement, means that some work that we will do on our image to give some details. Means that highlight some part, highlight some details. This is the act of the image enhancement. But in image enhancement, we have some work to do, or some technique that we maybe technique or some way that we can do that. One part is point processing. Point processing is the simplest kind of the range of transformation. Now you know that why I talk firstly about the transformation today, because we wanted to make this word clear. This independent of the position of x and y. See, G is equal to T and Y, and it's called the point processing. The important is that every pixel for himself as the spatial information which completely lost. And in this point processing, we have some obstacle. Is that if we assume f is the clone image and t is the random function, we can have something like that. G is equal to tf. Then you will see that if I do the point processing for some shape like that, the output will be like that. Then what we can take for these is that maybe we need some special information and need to restrict the class of transformation. For example, assume the monotonicity, something like that for the figure. This we talk regarding the gray level of the transformation and output of the gray level um, work, which it shows the some basic of the gray level transformation, which we can use for image enhancement. In that, you can see the dependency or relation between the input gray level and output of gray level. Let us see some example like this. Suppose some some picture regarding the medical job. This is the mammograph job. And this is the negative image which is obtained by the negative transformation. You will see some details will come out from this photo, and we can have maybe some more information that the original gray level picture. See more, suppose Fourier spectrum result of applying the log transform in some photo is showing here. And what we show that the working on the image with the gray level jobs and with the point by point, it has some obstacle and somehow it's not working well. Then we need to work more detail on this image enhancement. Suppose if you see this is the photo that I bring here. The first one is the real image. Second one is resulting of the transformation, but with the different uh, parameter settings. Suppose for number BCD, you will see that in the formula that I show you, C and gamma has the variable value of 3, 4, and 5, and respectively, you will see the difference between the image. Means that this image enhancement make our photo more clear, or what exactly it has done. It bright the edge of the image much more better, as you will see, compared to the first image and the last image that I have. More work, if I want to show you. This is the contrast scratching with the help of the transformation function. A low construct is the number B, and the C is the result of the construct scratching. And D1 is a result of thresholding job. If you are searching for some object or wanted to take some information about these seeds, or this is not actually seeds, these are some medical figure. I think the D1 it has more information for you if suppose you want to count just this object. Anyway, this is the point processing which we are using image enhancement. But one of the good methods in image enhancement is histogram processing. That uh, this is the main talk for our today. And from this part, we can now analyze with the help of MATLAB toolbox. In the later lecture that we have, we are working with the help of this histogram processing job. In this histogram processing job, let us first see why we need the histogram. Histogram information reveals that image is underexposed. And if you see the histogram of the image that I shown here, you will see some band, some gray band here. Or the overexposed image, if you see on down, you will see that some band of before some value here. Okay. Um, histogram as the basic idea is finding the map of function of fx such that the histogram of the modifier of equalized image is flat, something, some uniform thing. The key motivation in this is that cumulative probability function, which we know it CDF, of random variable approximate a uniform distribution in this photo. Suppose a histogram of PDF uh, has some formula of this, some cumulative or some summation of H by T, and the output is S. Histogram of digital image with gray level, it's with the range of 0 to L minus 1 in a discrete form, as we show here. And we know RK as the KTH of gray level, and NK as the number of pixels in the image having the gray level of RK. Then, if we want to act the function of HRK on that, histogram of digital image with the gray level of RK, we can have this equation. Another concept that we should know, this is the normalized histogram, which is dividing each of the histogram at gray level of RK by total number of pixels in the image of M, which this K will be start from 0 to L minus 1. And the function of the P or K gives an estimate on probability of the occurrence of gray level RK. The sum of all components of normalized histogram is equal to 1. This is the sum things that we should note it. And also, uh, we should know and see some different histogram output. See, suppose on the dark image, we have some histogram like this, which is the components of histogram are concentration on the low side of the grayscale. With the bright image, you will see that the histogram components is we have the high side of the grayscale. With the low contrast image, we have the histogram is narrow and concentrated towards the middle of the grayscale. And also on the high constraint image, you will see that histogram covers the wide range of grayscale. Now, something that we want come to picture. Compare this image. Compare the result of histogram you will see that histogram itself can give us some evaluation about the image. The image is dark, image is bright, image has the low contrast, and image has the high contrast. Okay, this is now something like a scale that we're searching for the image. Okay, now have it in your mind that we find the first analyzation or first things that we can do with the help of histogram and image enhancement. The equalization in a histogram is either is something like that. We apply the monotone transform resulting in an approximately uniform histogram, something like that. And monotonically increasing the function, showing how multiple value can map to the simple value. Strictly monotonically increasing the function. This is the one-to-one mapping the both way. As you will see here, the figure show us the transformation and act of that on the uh, histogram. This is the rough idea about the histogram equalization. And if you want to have the formula, means that how it will work, it has some cumulative part that we say act on the uniform quantization, and then we have the cumulative probability function, which is shows here, and we can have the formula. Once more, compare the act of histogram or result of histogram and the image that you can see here, the different range of the gray level, which is monitored here on the photos. Then equalization is something like that. If you put the histogram on that, then you will see that the right side and left side image um, quality and work as shown here, and uh, they show it here. Histogram equalization have some formula as I show you, but once again, if we want to represent the formula regarding that, we can say that in suppose Uh, in the formula that I show is equal to STR, which is the famous one we review several times during our lecture. R is represent the inputs of gray level in the interval of 0 and 1, where R is 2, R is 0 represent the black, and R is to 1 represent the white. And if we want to produce the gray level, S in the output image of every gray level are in the original input image. And this transformation is to satisfy the following condition. Means that TR is the single value monotonically increasing the interval of R between 0 and R, and TR is between 0 and R as we showed here. But for this formula, uh, you should know that uh, in this condition, we preserve the order when R is varies from black to white and guarantees the mapping that is consist with the allowed range of the pixel that we shown here. Um, okay, then um, just review this point. Then you will see that the single valued function, which we call it TR, will guarantees the three exist of an inverse transform, something like that, which that satisfy the same set of condition of A and B, uh, and as we show here. And if you will see for the formula and review this formula, you will see that if P R represent the probability density of density function of PDF of the random variable, R and PS will represent the probability density function, which we call it PDF of random variable. And S in this function is from the basic probability theories. Just review this formula. I want that you have the idea about these. Uh, you will see that we have some formula which is represent the probability density function and some variable like R and S, which is monitored in this equation. Histogram equalization is to control the probability density of the uh, image. And as we shown here, it's PDF, which from now we call this probability density function as the PDF. Please don't mix it with the PDF file which we have in Adobe Acrobat. We know it as the PDF of gray level of an image via the transformation function, so that the resulting is the uniform density. Exactly what we are searching in the histogram is this uniform density. And this is achieved by taking the cumulative distribution function of CDF, or the cumulative distribution function. We know the abbreviation of CDF. And R is required the transformation function as we shown here. In this in this formula, just review it once more. You will see the integration of PR W and with the differential of the dW. W is the dummy variable of integration, which we have in this histogram equation. Then, with the transformation function, what exactly will happen is that the PDF of PS of become S. Just review this formula. And we wanted to know that what the mathematical part will do. It's something like that, if you have the integration of PRWD, and then if you take the differential from that, you know that differential and integration, it has the inverse action to each other. Then with that, you can substitute and yield the PR of the equation that we have. Then the probability of occurrence of the gray level in an image is approximated by PR nk divided by n, and the discrete version of transformation is something like SK TRK, which we can show it here as the cumulative part of this probability occurrence. The histogram equalization in the discrete form can be something like that. There is the method which can be obtained the uniform histogram for the given image. You can see this image which we show here, and in that it shows the PR related to the R value which we have as an example. Hence, the required transformation function is something like S is equal to TR. And we know that this TR term is equal to the integration between 0 to R, PR, W, dW. And then for that, we can put the formula. Then the solving about this equation, we can have two values for the R. One is line in the interval of 0 and 1, and only function is valid is what I shown here for you as an example. One more example will show us the domain which we have the equalization. It's between 0 and 1. And this part is just the proof which show us that after the equalization, you have the value between 0 and 1. Once again, see the photos and work of histogram equalization. You will see the histogram as well as the dark image, bright image, low constraint, and high constraint image. One thing that we should know is histogram specification, which is in that this is the method to obtaining the particular histogram shape capable of highlighting the certain gray level range in the given image. If we know as the PRR and PS, which represent the original and desired probability density function, or PDF, respectively, then the histogram is specification is achieved by these following steps. In the first one is equalize the level of the original image via the transformation function, which we had before, and specify the desired probability density of function PZZ and obtain the transformation function. Apply the inverse transformation. Z is equal to G inverse S. The level equalize in step 1. The resulting image has the gray levels characterized by the specified probability density function of PZZ and has the specified histogram. In practice, the inverse transformation from S to Z is not the single value, and this happens when there are unfilled of level of specified histogram. These unfilled level make the cumulative distribution function to the constant over the unfilled interval. Let us see one example. If I have the PZ function of 2Z and Z, when Z I know between 0 and 1 as this function, then if I want to take the integration of this formula, I know that it's become to 1. And we would like to apply the histogram specification with the desired probability density of PZZ as shown here. Obtain the transfer function of TR will become something like this. And after taking the integration, you have the minus R rises by 2 plus 2R as one of the mapping 1-to function. Then in the step 2, as we discussed, we have the integration of 2W between 0 and Z, and it's equal to Z power by 2. And in step 3, we have the obtain the inverse transformation of function G inverse, and then we can guarantee that Z is between 0 and 1 and R is between 1 and 0. This is the act which we expected from the histogram, and what we know about the specification and equalization act of histogram. Today I talk more regarding the histogram and how it will act and image enhancement, which we will continue again in the next lecture. But what from next lecture we have? First part, we have some MATLAB comment, and second part from next lecture, we have some concept like this, which is we will start from noise model of function.